Corporate finance practice problem using OneNote. Find bond market rate or yield. Get ready, it's time to take your chance with corporate finance. Here we are in OneNote. If you have access to OneNote and would like to follow along, you're not required to, but if would like to, we're going to be in the icon on the left-hand side in the practice problems down in the 1028 Find Bond Market Rate or Yield tab. Also note that when using OneNote, you might want to take a look at the Immersive Reader tool. Many of our presentations up top will be mirrored down below in the text area. The text area having the same name and number, and those being transcripts. Transcripts that can be translated into multiple different languages and either listened to or read in those languages, thereby being a good complement to the presentations up top. Closing this back out, we have our information up top, and we're going to calculate that on down below. The information includes bonds outstanding. This is the information we would consider to be assumed to be with the bond or on the bond. Par value 1,000%, 8%, matures in 10 years. We're going to assume that these are annual type of bonds. The selling, we're going to say it sells for the 1,090. Then we're looking for what the market rate or yield is. This is different than what we've seen in the past. Typically, what we have then is the information on the bond, the 1,000, the 8%, the 10 years in this case, then the market rate. Using the market rate then, and these two calculations, we find then the price. You would think then that we could kind of take the price and back into the market rate easily, but it's a little bit more complex mathematically to do that, so we'll take a look at that and why would that be. Let's think about what we've done in the past first, and then think about how we want to approach this particular problem. So in the past, we have to present value two things to come up to this price if we had the market rate. We'd have to present value then the annuity, which in this case would be the 1,000 times the 8%, the payment that we assume to be happening every period for 10 periods, present valuing that using the present value of an annuity calculation, that including the market rate down here and here in that calculation, and we'd have to present value then the end number, the 1,000 that we're going to get, the par value, the maturity value, and we'd use that present value of 1, which also includes the calculation of R, which would be the market rate in it. So because we have these two formulas, typically we add those two together to get the selling price. It becomes a little bit more difficult for us to then solve for the unknown of R here. We can do it. We can do it mathematically, but it's kind of more complex than you might think. It's kind of mean to make you do it mathematically. Right? So we might want to take these two concepts then and think, okay, well, how can I basically take this calculation and back in then to the market rate if I have the price? Now, in Excel, we have a feature called the goal seek, and I'll just basically list it or explain how this process can work here. If you want to go into an Excel and do this process, then we do have a practice problem that you can work in there as well. So if we were to think about this, we could say take these two calculations instead of me trying to solve for them mathematically and put them together so we could solve then for R, we can then basically make assumptions about what the beginning number is, the rate, then do the calculation for the two components, the present value of the annuity, the present value of 1, then get to the ending number, and then we could basically change this one with trial and error. We could basically then change this with trial and error, which can be done very easily with something like Excel, which can help us out with that. Excel also has a calculator that's a bit more straightforward that we can use down here to get to that number as well. So we'll take a look at both of those examples. Formula way down here is the rate formula. So it's actually a little bit complex too. It's almost easier in some ways to do it this first way if you're used to calculating the bond value for the price, and it's a little bit more kind of, it's a little bit more intuitive to do this way. So what we would want to do then is guess what the rate would be. And note, you can also apply this concept to the formulas. You could basically say, I'm going to calculate these formulas and then add them together, assuming a particular rate. And then I'm going to change that rate until it gets to the end result we need to be, which is going to be the 1,090. So instead of us kind of reworking it algebraically, we're going to basically do our normal calculation and then force the answer based on trial and error of changing the rate until we get to the end result. So you could do that mathematically. Of course, that would take a lot of time if you did that with a calculator, but the concept would be much the same. If we do these calculations with Excel, we could do the present value here, the present value of the annuity, assuming a rate, which is guessing a rate of the 5%, present value calculation then being the rate, which we're going to assume of that 5%, comma, number of periods, which would be then the 10 number of periods, comma, the payment, which would be the 1,000 times the 8%, because it's the annual payments. That's going to be this component. That would give us the 618 about for the present value of the annuity, which does take into consideration R up top, R here, which is what we're basically looking for, and are assuming to be 5% to be our starting point. Then we're going to add the present value of one calculation, the present value of the 1,000 in our case, present value of the rate, that's going to be the assumed rate, the 5% that we're going to change, and then comma, number of periods, once again 10 in our case, because it's annual, comma, comma, because this time we're talking about present value of 1, the future value, that being the 1,000. So we pull that 1,000 back to the 614. If the market rate was 5%, then the 618 plus the 614 would give us the 1,232. Now, once we have that number, we can then say, okay, let us change now the market rate until we get to this bottom line number, the 1,232, to be what we know it should be, which is the 1,090. And that's how we can basically back into this calculation. That would be difficult to do mathematically this way, but with Excel, the tool GoalSeek allows us to do that. We could tell Excel, set this cell, set that number to be what we need it to be, 1,090, by changing this 5%, which is part of, as you can see, both of these two calculations, both in terms of the formula, you can see it up there, and in terms of the rate calculation, these two calculations being dependent on that 5%, then GoalSeek will then change the rate and kind of force the rate to be that 6.73, the rate that it needs to be in order for the calculation to be correct. Then we can basically double check this problem and basically work it again to see if we get to the end result of the 1,090, which is what we want it to be. That's going to be the 1,090. We can then say, okay, now let's take the present value of the rate, which is now that 6.73 about, comma, number of periods, which is going to be 10, and then comma, and then the payment, which is going to be the 1,000 times the 8%. We now have the annuity at the 569, and then if we present value then the 1,000, present value of 1, we've got the rate, once again, the 6.73 now, comma, number of periods would be 10, comma, comma, because now we're present value 1, the future value would be that 1,000. That would be the 521. Adding those then together gives us the 1,090. So that's one way. I think that's the most intuitive way to kind of approach this. And with Excel, you can basically do that. I think that's an intuitive way to do so. Then you can also use the formula here, which is going to be the rate formula. Now, as you use the rate formula, it's a little bit more complex because you got to make sure that you have the right negative signs in there. As we've been using these present value formulas, you'll note that we've been entering in there with a negative, so we can flip the sign to make it a positive number. This formula, because it's a bit more complex, you got to make sure that you got the proper negatives in place. You can also use the dialog box to help to calculate this one, which we will do when we do this in Excel, if you want to use this one in Excel. So this is the more straightforward way to get right there in Excel, but again, it's a little bit tricky to get there, and I would still basically verify it by, once getting the rate using this function, doing our normal present value calculation here to verify that you're getting the total of the 1,090 that you would expect to get if you had the market rate and we're then calculating the price. So this one looks like this, and again, if you want to see it in Excel, go to Excel problem. We do have this in Excel. It's going to be the rate, the number of periods. The number of periods is going to be 10, comma, then the payment. Note the payment here, I have negative amount. We have to make that a negative to make this work, which would be the 1,000 times the 8%. That would be the annuity portion of the payment. And then comma, we've got the present value. The present value then would be the 1,090, because that's the price, which we're assuming is the present value, comma, the future value then is going to be kind of like that future value of one component, which is going to be that 1,000. So that's the 1,000. If you enter that in, and notice that last 1,000 also has a negative in it. If you enter that in, then we should get once again to that 6.73. Once you get to the 6.73, I would still double check it just to double check this rate formula with what we're more familiar with, most likely the calculation of the price using the rate, doing this calculation again, present value of the annuity based on the rate that we have now found, present value of 1, double checking that the end result number then actually is the end result number here for the selling price that we used in the rate calculation.